Alright, this video covers parabolas in intercept form. Sometimes we call that factored form, because you have to factor to get there. Alright, make sure to check your announcements for due dates, deadlines, all that good stuff. Right here we have our different formulas that you need. Alright, this is what intercept form looks like, which is factored. I do want to point out that if P or Q happens to be a 0, your factored form can look something like this. Okay, so let's talk about the zero product property. So the zero product property, you just don't know that you know it. It says if you have two numbers, okay, we just call them A and B because we don't know what those numbers are. And it says if you multiply them together and the product is 0, then one of the numbers has to be 0. Which you know that. Most of the time if I ask kids and I go, hey, what do you know about one of the numbers if you times them together and it makes 0? You guys know it, okay? Now, the zero product property is a key concept for us to use when we move forward in algebra. So most of our rules and stuff don't work if your equation's not equal to 0. So neat, cool, very important property. We love it. Now, before I get into doing problems, I need to warn you. This concept was developed by different mathematicians in different areas of the world. And so what ends up happening with that is the x-intercept suddenly got a bunch of different names. And they all mean the same thing. They all mean x-intercept. But sometimes we call them roots or zeros or solutions. So if I'm using other words than what you know, that's because we like to confuse you. Congratulations. All right. So we're going to identify the zeros, okay? Just from the equation. Now, what you do is you look for anything that has an x in it, and you're going to say equals 0. Now, the 3 here, he doesn't actually change the equation. He doesn't change your roots. Because what I could do is I could divide both sides of the equation by 3, right? This side would cancel out. And here, 0 divided by 3 is just 0. So he does not matter. This one that has an x matters, but the 3 does not because he doesn't have an x. Ignore that. Okay. So for the zero product property, I'm taking the things that have x's and I'm setting them equal to 0, like this, which creates too many equations, which you then solve. So here, to undo the subtraction, I added 6. Here, you have to get rid of addition before you can get rid of multiplication. So I subtracted to remove the addition, divided by 2 to get rid of the multiplication. Now, sometimes we're good with just saying x equals blah. Or if it specifically asks for an x-intercept, you have to write it as an ordered pair. So look at your phrasing. This is asking for a 0, so you could just say x equals blah. Okay, so this one, right? I have an x, which is in front of the parentheses, so I say he equals 0. And then I take the stuff in the parentheses and equal 0. So a little subtraction to get rid of that addition, and I get x equals -4. Okay, this one right here, you don't even have to do any solving. You just get x equals 0 as one of your solutions. So what this means is that these graphs are crossing at these x values, like this or something. You'll see it in the graph that we do down here. I'm trying to go fast because I recorded this video once already and it took me about 28 minutes. Trying to beat that time. So I just realized I can't do this one, right? So pause for a second. Think about why I can't do this one. This is called the zero product property, right? Is that a zero product? So we're going to say, you can't do this. It must equal 0. Now, I will say you can do this, okay? You would have to multiply these out, subtract 3 from both sides, and then refactor, which may or may not be factorable. For the purposes of this video, you can't do it right now. Alright, so now we're going to practice our good old graphing. We love graphing. So I actually start with the x-intercepts here in the intercept form, because we need those to find your axis of symmetry. So for my x-intercepts, I'm going to take the stuff that's in parentheses, the x plus 1. I set that equal to 0. And I take the x minus 3, set that equal to 0. So this one, I would subtract the 1 over. This one, I add the 3 over. So my two x-intercepts, mind you, this one says x-intercept, so I have to write it as an ordered pair, are here. So then from that, now I can find my axis of symmetry, because the axis of symmetry uses the formula x equals p plus q all over 2. So these intercepts are the p and q values that we're talking about. So I would say -1 plus 3 over 2, which is 2 over 2, which is 1. So I say the axis of symmetry is that x equals 1. Now, just like with standard form, to find your vertex, right, that's a point that lies on that axis of symmetry. So I'm just going to plug that 1 into the equation. So I'm finding f of 1. Don't forget, your a value there is a -1. Oh, I wrote an x and not a 1, didn't I? Silly goose. So, you need to make sure not to lose your a value that's in front there. Sometimes we do our work with p and q and forget that the a exists. But the a is really important because it tells you how low down or how high up your vertex goes on your axis of symmetry. So here I'm simplifying the parentheses. So 1 plus 1 is 2. 1 minus 3 is -2. Oops. And if you multiply all that stuff together, -2 times -2 is +4. So your vertex is at 1, 4. Let's graph it. So here is x equals 1. 1, 4 is hanging out here. Your two intercepts, right? We had 3. And we had -1. And I know that I'm kind of on the right path because these are both 2 boxes away from your axis of symmetry. And just this rough shape so far, the parabola is opening down. But remember, you need 5 points total to graph this. So I'm using my a value. My a value here is -1. So what that's saying is when I come here to the vertex and I put my pencil on it and I go 1 box to the right, -1 says I'm going 1 box down. So without any calculation, I know that 0.23. And if I reflect it, right, if I go the opposite direction to the x-axis, I get 0.3. And that comes because the graph is symmetrical. So my anchor point, 2, 3, and 0.3, those came from my a value. If I couldn't use my a value because it was already used, I would just find the next point to the side, right? Like I might try 4. And then here's my little U shape with my arrows at the end. All right, let's try it again. I'll do it in blue this time. So this one's not in factored form, but I want it to be. So to start out, I'm just going to write this real tiny here and kind of regret it later. I'm subtracting 8 from each side. Okay, so I get x squared plus 2x minus 8 equals 0. And then we're going to factor that, okay? You could either use your reverse box like you've learned, or you can use the double bubble. This one's double bubble because there's a 1 here, right? So my fall down sign is a plus, he falls down. And with the choice sign of a negative, my parentheses need to have opposite signs. And I say what multiplies to make 8, that subtracts to make 2, and that would be 4 and 2. So there we are, we're in factored form. Now we're going to find stuff, okay? So let's start with our x-intercepts. So to find the x-intercepts, no need for parentheses here. I say x plus 4 equals 0 and x minus 2 equals 0. So I would need to subtract 4 to move it over, and I'm not showing that middle step. If you need the middle step, do it. But I feel like we're doing enough writing that it's okay to not show that I subtracted 4, because I know 0 minus 4 is negative 4. Same thing with the 2. I know that I added 2 to get positive 2 there. Oops. So those are our P and Q values. So now I'm going to go find my AOS, right? My axis of symmetry. So we have the formula x equals P plus Q over 2. So I have negative 4 plus 2 over 2, which is negative 2 over 2, which is negative 1. So I have the equation x equals negative 1 for my axis of symmetry. And then for my vertex, I'm taking the equation. Instead of having 0, I'm just saying f of x, and I'm replacing x with negative 1. All right, because an equation can't have a y value if there's no y. And f of x is the same thing as y. Okay, so when I plugged in negative 1, I'm simplifying my parentheses. So negative 1 plus 4 is 3. Negative 1 minus 2 is negative 3. So I got negative 9 for my vertex. So let's start there. Now my graph paper isn't quite big enough. My graph paper went to 7. And that's okay. It's falling off here for negative 9. Just label it so that you know later on when you're looking at it that like, oh, that's at negative 9. You should be okay. My two intercepts are negative 4 and 2. 1, 2, 3, 4. Oops. That's not a 2, silly goose. That's a 0, right? Because it's on the axis. The 2 is here. Now for my fifth anchor point, again, I'm going to use my A value. So here in the factored form, there's just a 1 chilling here, which tells me when I go to the side from this vertex by 1, I go up 1, which would put me here at 0, negative 8. Now this is 1 box from this way. So if I go 1 box to the left, which puts me right here at negative 2, negative 8, I have a fifth anchor point. So my two anchor points were 0, negative 8, and negative 2, negative 8, and there's my 5 anchor points. We're going to draw that U in there with arrows. All right, let's talk about conversion real quick. So to convert to standard form, I'm ignoring my A for a second, and I'm using my box to multiply together my binomials. Some of you guys multiply your binomials without boxes. That's fine. You live your life. Just remember, you're multiplying the numbers in front, and you're adding the exponents. And then I'm going to combine my like terms. So the 8x and the negative x will have to combine. So right now I have f of x equals my GCF that I ignored at the beginning, and then all my stuff from my box. And the 8x and the negative x come together to make 7x. Just kind of highlighting to help you see that. And then I distribute the 2 that's there. Okay, in this case with a triple rainbow. So 2 times 2x squared is 4x squared. 2 times 7x is 14x, and 2 times negative 4 is negative 8. So this is my final solution. Let's do that again. Okay, so I ignore the A value. I multiply, probably with a box. So I get 3x squared minus 6x positive 8x, and a negative 16. So don't forget your a. That negative is still hanging out. And then I'm unpacking the box, right? Which means, the 8x and the negative 6x have to combine like terms here. That's where I'm getting the plus 2x from. And then I have to distribute this negative. So when you have a negative out here and you send it through, you just flip the signs of everything that you have written there. Which isn't too bad. It's pretty quick arithmetic. All right, this last one, I ran out of space last time I wrote it. I don't know if I have fixed the photocopy by the time you see this. Use your imagination. This was magically 38. Sorry, guys. All right, so Janny throws a ball. It travels back down to the ground. Now, at this point right here is where it hits the ground. The x-axis is the time. The y-axis is the height. And they're wondering how long till it hits the ground. So what is that x value there? So what I need to do is I need to factor this thing. Now notice your leading term here is a negative. And that's a no-no. We don't like that. So I'm dividing the negative out. And just like I just described, that changes the signs of everything else in the problem. So then I'm going to use the reverse box to help me with factoring this. So my 16t squared is my first term. He goes here. Negative 5 goes here. And we would squeeze in a little tiny t table, right? So 16 and negative 5, your AC values. That's 80. And then my choice sign's subtracting. So I'm subtracting to make 38. Now, the two numbers that multiply to make 40 that subtract to make 38 are 40 and 2. Now, looking at this equation, this 38 is negative. Okay, that means that the 40 here has to be negative in order to, the 40 and the 2 to combine to make 38. All right, so now I'm going across my rows. I'm hoping that you remember your factoring from your last unit. I'm trying not to go too far into detail for the sake of the video. Remember, if you need more help with that, ask questions during class. Like I can walk you through those steps. Okay, so we're at this point. So one of these two parentheses will solve to make this. So I'm going to come here to the side. And I'm going to make the mini equation. So I say 8t plus 1 equals 0. And I say 2t minus 5 equals 0. Okay. So I have to get rid of the subtraction, or the addition first. And then when I divide by 8, I get t equals negative 1/8. But that doesn't make sense, right? Because t's talking about time. You can't throw a ball and have it go back in time. It doesn't work that way. So in this case, I'm adding 5 to get rid of the subtraction. And when I divide the 2 out, I get 5 halves, which is 2.5. And that's a reasonable time because it's positive. It would make sense that time passes when you throw a ball. Now, this is a word problem, so I'm going to give it a word answer. It would take 2.5 seconds for the ball to hit the ground. Alrighty, y'all. So there it is. Intercept or factor